Who here had too much to drink at the weekend? A headache? Wake up with a headache? What did you do to try and treat the headache?
Take some paracetamol.
Did anybody try anything other than paracetamol? These kind of things?
For example.
For example.
Continue to drink.
Yeah, more drink. Yeah. Iron brew apparently is quite good. Go for a try. Has anyone consulted a neurologist and tried to get brain surgery for their headache? Good. That would be kind of silly. So why do we not do that? Why don't we attack the part where the pain is? Why don't we go straight there? Yeah, because we understand our body's a system. Yeah, and there's parts in our body. The parts in our body interact. Yeah, and we can apply a pain relief to one part of our body, and it will go and hit the point of pain. So we're kind of all systems thinkers anyway. So we could probably just wrap it up right now. We're not really systems thinkers. We're not really taught to think that way. We think in a more mechanistic way. Our kind of general train of thought is analytic thinking, where we take problems, we break problems down into the parts, and then we reconstruct the parts into an understanding of the whole. Yeah, this is often called reductionist thinking. Mechanism is a philosophical theory that's born from this. It's from around about the 1800s. It was René Descartes. He believed that living things, humans, were just complicated machines. There was no kind of intrinsic relationship with the parts. Yeah. So this is analytical thinking, and this is what we generally do. When we design organisations, our organisations are usually formed around analytical thinking. We take our organisation, we have a purpose for this organisation, and we break it down into parts. What we have is a sales department, a marketing department. We'll have, product development, manufacturing, IT, whatever, and then we'll take IT and we'll break IT down into parts as well. We'll have analysis, development, test, different sort of points within that organisation. We'll have people who play the roles in there. Yeah, we discussed this earlier on, people who play roles in their UX or developers, yeah, and that's what they do. That's the thing, that's the part they play in these systems. But this kind of thinking isn't hugely successful. If you look at like employee satisfaction surveys from the US, there are 70-80% of employees in the US are disgruntled with work. We look at the Standish reports on projects, which is 50% of projects are challenged, or we look at the report on feature usage, and it's around about the same number of features that are developed in software that are not used. So there's lots of wasted efforts. Yeah, there's lots of wasted work, there's lots of wasted human potential even in there. So now, as we're talking about digital services, we're talking about new ideas and new things. We need to start to sort of evolve our thinking. Yeah, going beyond this industrial thinking, industrialized thinking, going beyond still the kind of automation thinking of software development, where we're just going to automate people's problems, into new thinking where we need to identify new novel ideas, yeah, to develop new software to produce for our customers. This is kind of coincides with the evolution of our understanding of capital. So we used to think of capital as being just the things, just the factory, just the machines. Yeah, then we realised that in the kind of Drucker's human resource type world that it was humans, that's where the capital was, so we had human capital. It was the humans that powered the machines, that ran the machines, so they were valuable to our organisations. And then that evolved to think, well, it's what the humans know that's important, so it's intellectual capital, that's the important thing. Now we're going beyond that, now we're starting to think about social capital, the capital we get from people working together. That kind of thinking is systems thinking. That's where systems thinking is kind of in. It's the sort of sweet spot of that. So to talk about systems thinking, let's go back and look at. I'll take a reductionist approach to systems. Right, I'll break it down into parts and I'll explain the parts of systems. So this is Donella Meadows. She's a famous systems thinker. This is her definition of a system. System is an interconnected set of elements which is coherently organised in a way that achieves something. Or a system is parts which interact to meet a purpose. Yeah, really simple. You think about manufacturing line, for example. Yeah, the parts on the system, the workers, the machines, they all interact to build the thing at the end. Yeah. Acuff would say that systems are interdependent. Each part of the system, when it affects the system, is dependent on its effect for some other part. In other words, systems are interdependent. So if you take the human system, for example, I want to pick this back up. What am I going to use to pick my clicker back up? Foot. You don't want me to take my shoes off.
Your left hand.
My left hand, okay. Oh, yeah, okay. So, yes, my left hand, but my left hand is dependent on other parts of my body to do that. It's dependent on my wrist and my elbow, my upper body, my feet are moving now to pick this up. It's not just that part. The parts are interdependent. My cardiovascular system was involved in that. Didn't, get breathing while I was doing that. So let me give you a kind of a nice example of interdependent systems, and it requires the front row. Yeah. If you like to stand up, and we have some space. I was wondering whether or not we had enough space to do it. If you want to kind of move in a little bit, this might be a bit of a mess, but we'll give it a try. Give it a try. So I want you to silently identify 2 other people in the group that's standing up. Probably have to come in a little bit or move back a little bit to see if we can. Yeah. Silently identify 2 people that's in the group. Don't tell me. Don't tell them. Don't do that kind of "it's you" thing. Yeah. Now what I want you to do is stand equidistant from those 2 people. So if you stand 2 meters from one, okay, good luck. Stand 2 meters from the other. Yeah? Want to try it? Yeah? Go for it.
That's not going to work, is it?
I'll get out of the way. Oh, unless you chose me.
Oh, this is spooky.
So we can see the elements of our system interacting, and we can see the interdependence as one moves, then not necessarily the direct part, the part that's touching moves. Other parts move. Yeah. Well, we can sit down. I could take this a little bit further, but we'll leave it at that. So our parts are willing volunteers. Interactions are clearly movement. What's the purpose of that system? Just have a laugh, to be honest. So yeah, the elements of the system are interdependent. Acuff would also say the defining properties of a system are properties that none of the other parts have, or none of the properties of the whole that none of the parts have. Yeah? So what's the defining properties of an airplane? It flies. Yeah. It's Ryan there. Oh, it's lighter than there. Right. Okay.
In motion.
Any more? Wings.
It can carry things.
It takes you from A. That's the defining property of a plane. A car is the same. Yeah. Acuff would also say things like your eye can't see, we can see. Yeah, your hand can't write, we can write. Yeah. It challenges you to cut your hand off and put it on the table with a pen and see how well it gets on its own. Yeah. Yeah. So, yeah, defining properties of a system are properties of the whole that none of the parts have. An interesting way in which you can sort of visualize systems is this little technique called stocks and flows. We have a really simple system here. We have one inflow, one outflow, flow in the stock in the middle. So think of a bathtub. Yeah, we have a bathtub. We fill it with water. There's an inflow. Yeah, and we pull the plug, and there's an outflow. Yeah. So often, if I would ask you to, how would we keep an equilibrium in a bathtub? How would we do that? Static amount of water in there. Same amount of water. You got it straight away. So yeah, it's not just the plug. Yeah, we were considering the interactions there, the inflow and outflow. That's not necessarily the way we think though. We normally think about just stocks. Flows are not something we tend to think about. Systems also have feedback in them. Yeah. Do you know where the term feedback came from? Anyone want to hazard a guess when it came around?
1960s.
Yeah. Yeah. With Clapton, no. It was the 20s. The term feedback was born in the 20s at the broadcast industry, and it's this kind of feedback, yeah. But no wonder, so Descartes' theories of mechanism is from the 1800s. Yeah, no wonder feedback is such a crucial part of a system. Yeah, you do something, you get some reaction, it gives you more information to do something else. Yeah. So here is using stocks and flows, and a kind of interesting way to describe or against draw feedback. And there's two particular kinds of feedback loops in systems: balancing and reinforcing. So balancing loop for a population is death. Yeah, it keeps it from growing too much. Yeah, lucky there. What's the population grown by what in the last how many decades? And the reinforcing feedback loop is births. Yeah. So obviously advances in medicine is making the reinforcing feedback loop much stronger. Yeah, infant death is down, etc., etc. We're living longer, so population is growing. Systems also have boundaries. Oops. Systems have boundaries. Yeah, if you're trying to understand the system, you need to put boundaries around the system. Okay. Yeah, in order to improve a system, you need to know where it starts and it ends. But this is difficult, right? Let's take a manufacturing system. What are the boundaries of a manufacturing system? Car manufacturing system. Let be the end. The car comes off the line. That's the end, right? So where would that's just an end. I've kind of suggested it may not be the end, but that for this purposes, this exercise, that's the end. Where's the beginning? Yeah, there you go. Yeah, sort of pulling raw materials. Yeah, so raw materials for what? The main organisation that builds the car, Toyota, for example. But then the systems start to grow. So if you start to think about, well, what about the suppliers? Yeah, and their systems and how they feed into this main system. And then think about, well, they need people in there to work there. So we need like recruitment. What about that? And then what about training? Before you know, you get into this kind of systems all the way, or turtles all the way down, infinite regress. Your mind's blown. Yeah. So you need to try and put boundaries around systems to understand them. Don't think of them as concrete though. They're kind of more like membranes. They're looser than that. Yeah. So, but boundaries need systems to be understood. Systems are also resilient. Not like dry spaghetti. It breaks. Yeah. Like cooked spaghetti. It's soft. It's malleable. It changes. You can move it around. Yeah. Human systems are very resilient. Yeah. We're resilient to change in temperature. Yeah, we are resilient to various viruses. We are resilient to impact. Yeah. Lehman Brothers, not so resilient. Yeah. Effects in the credit market, gone. All systems are also self-organising. Yeah. That's it's interesting. Imagine your micromanager, your kind of classic sort of hierarchical organisation where the micromanager sits at your desk and makes sure you do your work. I've heard of people who actually had managers leaning over their desks, watching them. This is rather interesting. But even in that system, there's an element of self-organisation. Yeah. Most classical self-organisations, like local community groups that are coming together to oppose the wind farm that's going to sort of sit right above the town, that kind of thing. Systems are also, time also plays a huge part in systems. So if you can imagine a shower, like a rubbish shower, you turn it on, you go in, the temperature's not quite right, you change the dial, nothing happens, you change it a little bit more, and then all of a sudden it's scalding hot water. Yeah? The delay in feedback as the waters get heated up in the system has caused you to act on the system again. Yeah? And then you turn it right down and it's freezing. And then you kind of get to that point where you manage to reach the point that's perfect. So time plays a huge part in systems. We all know it's an agile group, so we know about the importance of quick feedback, short feedback loops. If we don't do that, if we build on an assumption, for example, that our software needs to be like this and we're going to spend the next year building it, so we keep building and building and building and building and building, and then we've got a year till we get feedback on this assumption which was flawed. And the effect on the system is huge. Yeah. So you want to have rapid feedback in systems, or be conscious of the effect of time in systems. Emergence is a really interesting thing in systems. If you think about emergences, when two elements interact, something new comes out of them. Yeah. So it goes even further. When these two elements interact, something new comes out and then affects the behaviour of the system. This then makes the system a complex adaptive system. Social systems are complex adaptive systems. Anyone know Dave Snowden? You know Dave Snowden? So if you watch Dave Snowden, any of Dave Snowden's talks, or maybe his older ones, he gives a great example of a complex adaptive system. And it's a children's party. Yeah? So you had like 6-year-old children, there was one a few weeks ago. Children come together, they have wee ideas, they go off do something else, they come together again, they bang heads, there's all sorts of crying, they're ganging up on their parents, there's all sorts of things, there's interactions happening in that system, and new things, new novel ideas are coming up, and the system is moving in strange directions. With complex adaptive systems, in order to get some element of control of them, you need to put constraints around them. Yeah? So a constraint in a system like that would be a bouncy castle, yeah? Chuck them all in there, we know where they are. Yeah? Snowden's suggestion is you draw a line in the sand and say you cross that line, you little bastards, and you die. That's his suggestion. So yeah, emergence is where really interesting novel things happen in systems. So that's like systems 101. Systems thinking is just a way of understanding the world that emphasizes relationships among the system parts rather than the parts taken separately. Yeah. When we look at systems as well, we're interested in the whole system. We look at it holistically. The system's approach to problems focuses on the system taken as a whole, not on the parts taken separately. When we look at separate parts within systems and we change separate parts in systems, what we often end up with is sub-optimized systems. Yeah, we get little bits, so we increase the ability for our developers to work really, really quickly. And before you know it, our testers have got a queue this big. Yeah, and work doesn't get to the end. Our lead time to our customer doesn't get any better, it maybe even gets worse. Yeah, so when we consider changing systems, we look at them holistically. What is the effect across the whole system when we make changes? Here's a great example of a system that wasn't examined holistically. Anyone know a story? Operation Cat Drop. The Dayak tribe in Borneo, they in the 50s they phone up the World Health Organization and say, hey, we're dying here from malaria, could you do something about it? And the WHO, in their wisdom, decide to spray the whole area with DDT. That will kill the mosquitoes. Good idea. Yeah, mosquitoes go, malaria that kind of stops bothering people. But what it also did was it killed other kind of insects, other wasps. And these wasps used to eat caterpillars. These caterpillars would eat thatch. Yeah. So without the wasp to kill the caterpillars, roofs started falling on people's heads. Yeah, all these wasps were killed. And then geckos would come along and eat the insects that were killed by the DDT. And the geckos are quite resilient little systems. They could cope with large levels of DDT. But what would happen is cats would come along and eat the geckos. And then the cats would die. And then there was like a growth in the number of rats. And people ended up with typhus. So the World Health Organization parachuted cats. It's great, you can't write your stuff.
Did it work?
It may have, I think.
Yeah.
The story ended there, that's where it goes. So that was the interesting bit.
Just end it there.
Did they get the parachutes off? That's what
There's some great...
They land on all 4 legs.
So as well as it being not the way we're taught, not the way we think analytically, systems thinking is counterintuitive. It's counterintuitive. Well, anyone know who this is? Kahneman, Daniel Kahneman. So Kahneman's the author of a book called Thinking Fast and Slow. I highly recommend that. If there's any book of the books I'll list later on, in fact I don't even list this one, I would highly recommend reading Thinking Fast and Slow by Daniel Kahneman. He's a psychologist, and he spent a large number of years of his life working with a guy called Eamon Tversky. He met Tversky in the 70s, and Tversky was giving a presentation on humans as good statistical decision makers. He thought we were good statistical decision makers. So Kahneman thought, that's an interesting subject, let's work together and we'll research it. Very quickly they found that was nonsense. Humans are very, very bad statistical decision makers. Along the way they came up with a few models. There's two basic systems that they developed. One is, or they began understood in the brain. One is system 1, which is your fast thinking brain. So let me exercise this for you. Hands up, we know the answer to this question. 1 and 1. Oh, come on. Right? So 1 and 1 is, that kind of simple multiplication is something you've internalized. Yeah? System 1 is giving you an intuitive answer to that. So I'm using system 1, sorry Caroline, I'm using system 1 now to place my feet. I'm not thinking about it. It's not something that I'm having to really take in. There's not any cognitive load in where I'm going to put my feet. Yeah, that's the job of system 2. System 2 answers, and hands up for this one, 73 times 24. Yeah. So that's we have to, when you think about models, we have to really kind of work hard to understand that. So with those models, the system 1, in order to make many decisions that we need in life, they developed the concept of cognitive bias. Yeah? Cognitive bias are things like confirmation bias. Confirmation bias is that I have a belief about something, and I have a belief that Agile software development, it works, right? So every time I see Agile software development, I will see it working. My model, my confirmation bias is looking for positive outputs from that to say, yes, that works, and reaffirming my belief that that works. Anchoring is another cognitive bias. So if I was to give you the number 40 and then was to ask you how much, I don't know, how much was that case for the beer, chances are the answer you would give me would be anchored by that number. Even though it wasn't related, I didn't give you it in the same question, the answers would be related. I find this all the time. I ask teams to rate the effectiveness of a retrospective when they leave. And we used to do it with a chart, 0 and 10. And the first person to put a number, they put an 8. And then the rest of the numbers were 7, 8, and 9. Everything surrounded that number. When you ask people to do it blind, they don't see what other people are doing, you get a bigger range. So, quick detour in there, but the cognitive bias that is of interest for systems thinking is the idea of fundamental attribution error. Now, fundamental attribution error means that when we form an opinion of something, we do it based on what we see there, yeah, and we don't understand the connections, we don't understand what's happened round about that event when we make the opinion. So someone cuts you up on the motorway, you call them an idiot. Yeah? What an idiot. Why did they do that? Now if you cut somebody up on the motorway, you're not an idiot, right? There's a reason why you did it. Yeah? We understand the connections ourselves and why we make decisions. We can see the reasons for what we've done, but we can't see when someone else has done it. Okay? So we look at that, we can't understand that he was actually in a rush to get to the hospital for whatever reason. So what's that got to do with systems thinking? So this is Edward Deming. This is a kind of pseudo-ish quote of Edward Deming. Deming was is a kind of famous statistician and I guess management guru. He was sent to Japan in the early 50s in order to help the Japanese in the manufacturing industry and help teach Japanese managers how to manage organizations. He had this thing called the system of profound knowledge, and his theories for management. It's around 4 things. One is a theory of knowledge, what you can understand, what can be known and what can't be known. Yeah, known knowns, known unknowns, all that kind of thing. A theory of psychology, what motivates people. An understanding of variation, what demand is put on systems that varies each time. Yeah, so, and an appreciation of a system, an understanding of a system. That's what he taught Japanese managers. He believed that 95% of the performance of an organisation was attributable to the system and 5% to the individual. Yeah. This is kind of like a pseudo quote. This is taken from one of his 4 days with Deming classes. If you read what he's written, he says it's sometimes 94, sometimes 97 as a variation. I think he actually made it up, to be honest. I don't think it was one of these things that would be really hard to prove. However, let me give you an example of an organisational change, a systemic change in an organisation which had a profound effect in the performance of the organisation. So this is General Motors plant in Fremont, California. It was reported to be the worst manufacturing plant in America. It was definitely the worst manufacturing that GM had. It was probably the worst car manufacturing plant in America. And so with that, possibly one of the worst manufacturing plants in America. What would happen is the folks who go into work there would go in and drink. Go in and drink each day, You know, the stories of guys taking screwdrivers in their thermos flasks to have a few drinks. Many times the factory line couldn't start because people just wouldn't turn up. Yeah, there was drugs there. There was all sorts of carry-on going on in this plant. What that kind of led to was, I imagine, lots of kind of management worker tensions. Yeah, workers would then kind of be upset by this, and they would like scratch cars. They would put Coke bottles into doors. You open the door, something wrong with this. And there was one guy in particular who was so disgruntled he made cars unsafe. He would not screw bolts properly onto suspension. So you know, cars are coming out, and there was, I think there was roughly 400 found in the lot, the cars that had been built that were unsafe due to the things he'd done. Cars that would come out of this system were atrocious. You know, some cars, well, imagine what happens at the end of a factory line. You've built a car, what do you want to do with it? You want to drive it. You want to drive it out. Cars were getting towed off the line. There was cars were missing steering wheels, engines in backwards. You look at the back of the car and it's a Chevy whatever, and you look at the front and you go, no, that's a Vauxhall. There was no, you know, the quality was terrible. So GM decided that enough was enough, and in 1982 they closed the Fremont plant. Round about the same time, there was US legislation that said car emissions had to go down. I mean, they want to reduce the car emissions. You can imagine it's probably from like 5 litres down to 4 litre engines, but they had the emissions were going down, and the car manufacturing companies had to make small cars for people. At the same time, there was the threat of an import levy increase. So companies like Toyota, Honda, Nissan couldn't import their cars in a kind of a profitable way. So Honda and Nissan went and set up their own plants in North America. GM and Toyota did something different. They partnered up to create this plant called NUMMI, which is New United Motor Manufacturing Incorporated. GM wanted to build a small car. They'd never been able to build a good small car, and Toyota wanted to go into America. Toyota's approach is very much sort of small steps, continuous improvement. They weren't going to risk go to the same extent as Honda and Nissan did, would be just go in there and start afresh. They wanted some support. They wanted to do it in a kind of safe to fail way, I guess. So they partnered with GM. What then happened was one of the first people that was hired back or hired into NUMMI was one of the managers of Fremont. He was one of the kind of union leaders, a guy called Bruce Lee, and he asked, can I make the first 50 hires? Roger Smith over there, GM, said, no chance. We know what you're going to do. You're going to get your drinking buddies back in here. This place is going to be a mess. And Toyota, he said, yeah, go for it. Hire who you want. Fair enough. So it turns out that NUMMI ended up with 85% of the workforce from GM Fremont. It was, sorry, I missed the part that it was Fremont where they decided they were going to open this plant. Yeah. The other 15% of the workforce came from a Ford plant that was closed down nearby. So that workforce was in place, and what they started doing was they sent a number of them over to Toyota City to get trained in the Toyota production system. This was the thing that made these guys sign the deal. Toyota were going to teach GM the Toyota production system. It was one of the factors of this. So these guys go out, and there's two profound things that happen to them. The first thing is that one of the guys is asked to, before he starts on a particular role, he's asked to observe it and come up with improvements. He'd never in his life, 30 years of working in GM, ever been asked to improve anything or for his ideas for improvement. So this was quite emotional for these guys. The other thing was they were asked to pull a cord whenever they found a defect in a car. This thing's called the and-on cord, if anyone's familiar with lean. And it basically, what happens is if there's any quality problem identified by anyone in the plant on a particular car, they pull the cord, and within 60 seconds there'll be a team there trying to look at the problem and see how we fix the problem. If they can't fix the problem immediately, then the line stops, manufacturing stops, in order for them to go and find the root cause of the problem and fix it so that the problem doesn't continue. GM had no concept of this whatsoever. You know, there's guys were on the line in GM, and if they fell in the pit, The line would still go. Yeah, cars would go over the top of them. There was no concept of stopping progress. Management believed that if you had this cord, all they'd do is pull the cord, open another beer and carry on. Yeah, they didn't trust the workers to do that. So what happened then was the staff came back, some trained, and they implemented TPS, or Toyota Production System, in Numi, and within 3 months they had Toyota quality cars coming out of Numi. Yeah, the minimal defects per 100 cars. It was a huge transformation in this workforce, this organisation, in that short space of time. So just a quick round up of that. The sort of Toyota, looking at it from a systemic point of view, the elements of the system were the same, really. It was the same people doing the work. The interactions of that system, well, GM's theory was of theory X, Douglas McGregor's theory X, theory Y. Theory X basically meaning that people are lazy, workers are lazy, they'll skive, they won't do work. Yeah. GM also worked in large batches. Let's do lots and lots and lots of stuff. Yeah, big things before we put it out. Whereas Toyota had one of the pillars of the Toyota production system is respect for people. Yeah, they would respect the ideas of the people, and they would try to sort of harness the innovative capabilities of that whole organisation. Single piece flow, they wanted work to flow through quickly, and the concept of continuous improvement, always want to get things better. The purpose is one of the key things, I think, in this system that made the difference. The GM purpose is volume, make money. Ship it, ship it, ship it, make money. Yeah. GM's financial models actually are quite widely used in organisations now. These kind of ideas have permeated throughout. But Toyota had a completely different, they had a more oblique approach. They said we want to create the best quality sort of consumer cars. That's what their goal was. And those ideas then filtered right down to people doing the job on the line. So why, again, GM's theory was individuals and not the system. Success was built on high volume and low variability. So why was GM so successful in the first place? Is that when people wanted cars, there wasn't many options. They just had to take what they got. Yeah. Whereas Toyota recognised very quickly on that the marketplace had to be diverse and people would want different things. So they, again, looking at back to Deming's appreciation of variability, or understanding of variability, in the system, and they had the theory of psychology, etc. So you had the system of profound knowledge. So then, that's kind of quite a profound change in the system, and it's a good example of Deming's 95-5. Yeah, it was the system and not the individuals that made the change. So what about software development then? Is this applicable in software development? Is systems thinking applicable in software development? Quick question. Let's do the fundamental attribution error test. Has anyone ever heard when a defect is found in production, who tested that? Who was the tester that tested that? Yeah. Or who developed it? Who is the developer? Yeah. We're honing in on the parts, and not considering the kind of the interactions, the causes, what's happened around about, the context in which that occurred. How do I boo? Yeah. Waterfall. Yeah, this is page 2 of Winston Royce's paper. This to me is an archetypal reductionist thinking system. Yeah, we've broken the work down into parts, each of these stages. We have different people who will perform the roles in these parts, and then our communication within this system is not in any way collaborative. It's very much, I've done my bit, now you do your bit. There's no working together in that system. It constrains self-organisation, certainly from a fully systemic point of view. Yes, there may be points of self-organisation within these boxes, but it constrains it across the full system, so there's no chance for each of these points to work together to try and improve the interactions, I guess. Doesn't appreciate the impact of time. Example I gave earlier on, yeah, we'll make a decision early on. Yeah, we'll rush to certainty here and make this decision, and we'll build on that decision, and then when we're done, at the end, only then do we realise, hey, we introduce things like change management to stop any kind of outward forces, outside forces impacting the system. We don't embrace change in this system. It's a highly constrained and rigid structure. Yeah. So I guess the purpose of that system is to build on certainty. Yeah, we know exactly what we're going to do, or we can arrive at certainty very quickly. Whereas Agile approaches, it appreciates, this for me is the fundamental difference, is that Agile approaches appreciate that what we do is uncertain. Yeah? And the whole systems then grow from there. How do we build systems that manage uncertainty? So Agile systems, I guess, are designed to harness interactions, people working together. Harness the creative capabilities of the whole team. We were talking earlier about T-shaped people. Yeah, everybody involved in, some testing and looking at all of the different points. It's not just you do your bit, etc. Embraces self-organisation. It's one of the key things we do within Agile teams. Is we self-organise. We're around planning, around improvements, etc., etc. And that then creates resilience. Creates resilient systems. So we look at Scrum, for example. We have our backlog refinement. Yeah, again, it's about building shared understanding. How do we best get the elements of our system to interact together? We have planning. I guess does the same thing for us. The stand-up meetings, like a microcosm of interactions. We come together for 15 minutes a day, in a good stand-up. Right, we've all been in bad ones. Boring. But it's a chance for us to interact, to learn more. Yeah, we'll hear things about what's going on with other members of the team, and new ideas can come out of that. Some emergence from there. And the retrospective, of course, is that opportunity to self-organise. It reflects on how the system is working and how can we improve that system going forward. 3 Amigos. We do 3 Amigos. We do this. So 3 Amigos, bringing together a representative from the business, your product owner or analyst, depending on how you work, some developers, some testers, to come up with a shared understanding of what the story is you're trying to develop against, or what the work is you're trying to do. This gives the opportunity again for lots of people to bring their ideas together and increases interactions. So one of the things I normally do as a coach is try to get 3 Amigos in very early with teams, especially teams who have never worked together before. What I've found in the past is that if we've got a piece of work to do and we come together at the start of that piece of work, we've got this kind of shared understanding, this shared ownership of it, and people begin to work together and interact together through the whole flow till that piece of work is done. I've got a team that I'm working with just now. First time I sat down with them to do any kind of acceptance criteria for stories, they were doing this whole thing where somebody would start talking about the story, and they'd go, right down into this edge case over here, and somebody else would go to an edge case over there, and the conversations were going all over the place. What 3 Amigos does, in this case, or a kind of view to create acceptance criteria, would create enabling constraints. Yeah, it structures the discussion in such a way that we're going to go from with Cucumber, BDD. Here's a scenario, look at the scenarios and break down and get the scenarios. So it puts constraints around those discussions, helps us work in those discussions. Similarly with story mapping, again, another team in the same organisation, somebody presented UX sort of mock-ups, and before you know it, somebody's over here with one idea about this button, and somebody's over there with another idea about another button, and the conversation's all over the place. Yeah, story mapping that gave everybody the opportunity to focus on one point, and then bring all their ideas together. So story mapping would be typically 5 people looking at a flow of a project, a flow of a system, a piece of work, sorry. And how many times have I said system? I count. So they would come together, they would highlight maybe a user goal, and then they'd individually think of all the tasks that the user has to do to meet that goal, and then they bring them together. So you get a bit of divergence and convergence around the work. So it gives people another constraint around the complexity that can be involved in these discussions, and comes up with things that we're going to work on. So I have another one of those teams that are just conversations are flying all over the place, and you're like, oh, I can't keep up with this. Put constraints around it in order to try and help the interactions be better. So, however, is Agile a sub-optimization? This is John Seddon, this kind of famous system thinker. He suggests that Agile is the wrong thing faster, or can lead to the wrong thing faster. he believes that what often we do in Agile is we don't consider the whole system end to end. We talked, Tom was talking earlier on about the kind of waterfall sandwich. Yeah, we find that what happens is we've got Agile teams sitting in the meat of the sandwich, sitting doing the development in the sandwich, but we still have large amounts of analysis going on. We still have a requirements-driven approach. And then we have the other end of the organisation, which is all kind of operations heavy. Yeah, so it could be suboptimal. We could be going in here and we could be disrupting the whole flow of a system by adding in rapid development right into the middle. So
Wouldn't doing the wrong thing slower be closer?
doing the wrong thing slower, yes.
That's kind of a good thing.
Wrong thing
Because
slower.
you should be getting feedback on that.
Well, I guess in the system we described, you're not got the opportunity for feedback. What you've done is you've just iterated inside those boundaries. But yes, yeah. I mean, again, this is contextual because
It could be
yeah,
worse. It could be worse because if you've got something which is you've developed something really good, and you've got something either side which is working in a very unnatural way, then is that a lot of effort could be wasted on something which is not worth doing in the first place, and you should have stopped it right at the beginning. And if you're doing the Agile approach properly, you should have spotted that earlier on, and you should have stopped it. You shouldn't have gone that far.
so I think as Drucker says, nothing is as wasteful as doing with great perfection that shouldn't be done at all.
Yes.
So I guess the introduction of lean ideas in the last few years into software development has allowed us to start thinking about, it's encouraged us to start thinking about whole systems from customers' perspective. It's one of the first tenets of lean. Yeah, see the system from the customer's point of view, then understand the value stream, understand all of the value-adding work that happens between the customer wanting something and you delivering that thing. Yeah? Lean then suggests that we try and bring that value-adding work together, yeah, to help it flow better, yeah, and then iterate on that, try and make systems work better together. So Lean has kind of asked us to think a little bit wider, draw the system, in some contexts, draw the system a little bit wider. I appreciate that many Agile teams do have that customer interaction directly. I'm not kind of sort of suggesting that's not the case in many kind of contexts. But Kanban with that then, what Kanban does is when we introduce Kanban to teams, we take a systems thinking approach to Kanban. So we would look at what are the demands placed on the system, yeah? What are the how does the system work? We map that value stream through from end to end. Yeah, we then ask ourselves, where does the work go at the end? So we start to think a little bit wider. You start to draw the system boundaries a little bit wider than what can happen in some kind of Agile approaches where it's just very much Scrum team-driven development. So what else has happened is we've kind of ideas around lean UX. So what can often happen in Agile teams or with Agile is we can exploit the wrong problem. We can iterate around the wrong thing. Whereas lean UX allows us to explore, so we can create multiple hypotheses of what the problem state is, do really short, sharp iterations with lo-fi prototypes, etc., to come up with the right idea and then iterate, then exploit those ideas with Agile teams. We then have DevOps, the evolution of DevOps and how that's come along to then go through operations, yeah, and smooth the flow of work through operations. So if we see lean UX or Agile UX even, and then Agile software development, then through operations, we're starting to get this whole systemic view, yeah, where we're getting work to flow quicker in kind of larger orgs. So then is 95.5, click, is 95, oh, yeah, see, impact of time, double clicks. Is 95.5 applicable? I'm not so sure if that number is applicable, but I definitely believe that an appreciation of a system and an understanding of a system and how we design systems for people to work in is a fundamentally important thing when we're designing a better way of working. However, we've got to appreciate that working in these systems are people, and people have feelings and people have needs. Yeah, we've got introverts working in systems where interactions is a difficult thing. They want to work on their own. Yeah, so whether 95.5 is entirely applicable, I'm not sure. but definitely an appreciation of a system and how systems can be designed better to create better interactions is important. So that's me.